Today we'll look at handling geospatial coordinates within a 3D PDF file for enabling geospatial coordinate location probe and coordinate systems carried within the PDF. This will cover mixed assets with and without geocoordinates, for instance using an image based on a JPEG format plus a JPW world file for draping over a terrain, and the terrain being defined by a simple AutoCAD Civil3D terrain model exported to AutoCAD Classic and with manual geospatial coding added to it. As background, the PDF 3D tools include 3D PDF support and generation software, which can be used for many workflows, particularly when you want to share results with a wide community, remote staff, want to improve efficiency of communication, or even encrypt sensitive documents and models in an easily shareable format. 3D PDF documents can include rich interactive features such as location probing, turning on and off layers, and changing the elevation scale within the 3D view scene. Some of the applications for this include merging 3D laser scans with existing building designs for comparative analysis, or engineering infrastructure scanning so that new pipework and modifications can be planned. Let's look at some of the assets we'll use. This is a simple AutoCAD DWG file defining one part that's a triangle mesh of a 3D surface defined as a terrain. If we rotate it, we can see the lighting on the surface changes, so it's like a crinkly flat surface defining the 3D elevation model over a particular part of the earth. This model's been defined from a terrain model and then exported as a classic AutoCAD DWG file without any geospatial coordinates. In addition, we'll look at an image, in this case a JPEG image, and a world file defining its scale and orientation in a geospatial context. To get started, we'll use PDF 3D Report Gen and import the simple terrain DWG file and produce a new 3D PDF output file just from that one file. To set up for our geospatial output, we'll adjust a few things. On the PDF 3D View tab, we'll set a geospatial coordinate system for the views. On the Scene Axis tab, we'll enable a compass symbol instead of the standard XYZ axis. We'll enable a scale bar ruler along the X and the Y axis of the model. In addition, on the PDF 3D View tab, we'll enable a 3D probe for looking at location data and also a Z-scaling control. Converting with these settings, we get a 3D PDF file generated, and we can see our ruler scale bar on the X and Y sides, and we see the north compass in the corner here. So as I rotate, we can get an idea of the overall shape of the terrain. However, the terrain itself just looks like a crinkly plastic surface with very few attributes. We can enable the Adobe 3D Measure tool and take a look at distance across the surface. However, there is nothing there to give us the location of where we actually are on the Earth's surface. So looking at the coordinate system readout below the 3D view where we've enabled a probe, we can click on the surface anywhere and get the X, Y, and Z location on the surface, which is just a local coordinate system of this mesh, still without any geospatial coordinate data. To add location data, you can go back to Report Gen. This time we'll go to the Geospatial tab and we'll open up the Coordinate System menu. Here we can look at adding a geospatial coordinate system, in this case EPSG 27700, which is where this projected data is living for this particular model. And then we can also add our image at this point. So I'll get the image overlay here, this JPEG, and we'll also do a texture split on that, since typically anything over 4K by 4K can benefit by having a split for higher quality texture viewing within the PDF. The world file is automatically loaded anytime it's accompanying the JPEG. To adjust the image to have a better visual quality and remove the plasticky look, we'll go to the Visual Effects tab and adjust the material characteristics. First, we'll enable the diffuse color and set that to black virtually off. Also, the specular color we'll set to black so it doesn't have any effect. And also the ambient color we'll take pretty much down to 0. Then on the emissive color, we'll set that very high, virtually white, and this will let all the pixel data from the original image dominate the way the texture is displayed. Now if we convert with these settings, we'll have a look at a new 3D PDF file. This result shows our original 3D DWG mesh plus the image overlay as a texture within the 3D view. We added a Z scaling here so we can increase the height of the terrain artificially to magnify it. In this case, I'll use a factor of 10 so it appears more irregular. And we also have our probe available now. This time we can read out in latitude and longitude in our geospatial coordinate system for this model, or we can change it to the UTM local projected coordinate system zone, and we get the 30U indicator plus the eastings and northings within this zone and the elevation in meters. The interactive probe feature can also be used in other ways, for instance to look at distance between any 2 points along the model by 2 mouse clicks, or by looking at angle between 3 locations, or by looking at grade for civil engineering purposes where the value is reported in percentage, degrees, or a ratio. I hope this demo has been useful. If you'd like more information, please see pdf3d.com.